Good morning, everyone. This is Vishwas. So, today we are going to explain a few points about boiling and evaporation as we have already discussed this is in our previous video. So, let's have a brush up of this. So, what do you mean by boiling and trends? So, boiling occurs at a fixed temperature. So, for every liquid, there is a fixed temperature at which the boiling takes place. For example, for water, right? And evaporation is that process which can take place at any temperature. Water can evaporate at any temperature, at the normal room temperature also, right? Second, boiling is a quite quick process as you have to provide external heat. But as we compare evaporation is a slow process. It can take 1 hour, it can take 5 minutes, it can take 10 minutes also, right? So, third point, boiling takes place throughout the liquid, so we call it a bulk phenomena. Remember, I have already explained this is in the previous video that boiling is a bulk phenomena, but evaporation is only a surface phenomena. That is, evaporation takes place only from the surface, whereas boiling takes place from the whole of the liquid, right? Each and every particle gets boiled at the same time. So, bubbles are formed in the liquid in case of boiling process, whereas no bubbles are formed in the liquid in case of evaporation process. So, fourth point of differentiate we have over. Next point, temperature remains constant in case of boiling. As I have already told, boiling has a fixed temperature, whereas evaporation, the temperature can change with respect to time and with respect to the climatic conditions as well. So, last point but not the least, thermal energy supplied by an energy source in case of boiling. As I have already told you, an external source you have to provide for heating, whereas in case of evaporation, heat can be absorbed from the surroundings also. So let's see the figure for a better understanding of the concept of boiling and evaporation. In case of this figure, you can able to see only the surface molecules are getting excited as they are having the kinetic energy. Are you able to see this figure? Yeah. So vapor pressure is less than atmospheric pressure in this case. So bubbles are not getting formed over here. In case of evaporation, I am talking about. But when we consider boiling, as you can see, the vapors pressure is equal to the atmospheric pressure, due to which bubbles can form, as you can see these white bubbles, right? And the whole of the liquid getting boiled up, the temperature is getting rising, and the boiling takes place. So boiling is a bulk phenomena, whereas evaporation is a surface phenomena. Understood? So going to the next topic, that is, I have already told you I'm going to discuss about the two states of matter at last. But these are quite important states of matter. We won't include it in our CBSE syllabus, and there is not much in the NCRT as well. So, but I'm going to explain it to you. Plasma. What do you mean by plasma? Plasma basically is super energetic and super excited particles. Like, you might have heard of plasma in space, or you might have heard of plasma somewhere else also. Just try to remember. Have you heard of plasma TVs? Yes, yes. So plasma TVs are also based on the same concept. So what is this concept? What is plasma basically? The state consists of super energetic and super excited particles. These particles are in the form of ionized gases. So basically these particles are only the ionized gases. What do you mean by ionized is charged, right? They can be positive or negative charged gases. So the fluorescent tube and the neon sign bulbs consist of plasma that you can find in your day-to-day life also. Fluorescent tube you might have heard of, right? Okay. Going to the next topic, that is states of matter. In this, you can able to see this solid, liquid, and gases, and there are neon signs called plasma, right? So these are the basically four states of matter that I have shown. But there is one more state of matter. Can you name it? Think. I hope you haven't heard of Bose-Einstein condensate. That is the fifth state of matter that you are going to study about. Let's start. So Bose-Einstein condensate. Indian physicist Stenendranath Bose made a study regarding the fifth state of matter, right? That is Bose-Einstein condensate. Albert Einstein predicted a fifth state of matter called the Bose-Einstein condensate, or we call it as BEC also. So what is that? It is basically called a supercool state of matter. What do you mean by supercool? In case of solids also, so you have said that's a that can be obtained by cooling the liquid. So why this is known as supercool? So Bose-Einstein condensate BEC is formed by cooling a gas of extremely low density to super low temperature, right? So density and at super low temperature, what does it mean is, suppose focus here. This is a gaseous particle, ionized particle that is traveling at a certain speed, and when it is going to a temperature less than minus 273 degrees centigrade, right? So what will happen? It will just slow down its speed a little, right? This is the first sound that we have heard at the microscopic level, and this is the second sound that we have heard at the microscopic level. So, what is this sound all about? It is telling us about the speed of that particle, that it is going slowed down when the temperature goes on decreasing. So, at a time will come that that energy will be lost in the surroundings, and that particle will be converted into fifth state of matter that is known as Bose-Einstein condensate. This happens only at a temperature less than 273, right? So that's why we call as super cool state of matter. So in today's video, we have learned about the fourth and fifth state of matter, and we have revised about the difference between evaporation and boiling. I hope you all have understood. Kindly share it. If you have any doubt, you can post it in the comment section and like it. And for getting more videos of certain type, you can subscribe to the channel. Thank you and have a nice day.